person who's watching this, set up these volume integrals. Just set up, but first find that intersection. Sorry, Fairly. Yeah, it's one of those days where I feel like I'm in everybody's way. I just like, yeah, go home, go to bed. Do we have that intersection point yet? Do we know where that region starts? What do you think? 4. 4. Yeah. So make sure that you can get a 4 for this intersection point. That's going to be your integration range from 0 to 4 for all the integrals, because we're doing vertical slices. And if you're not quite sure how to get that, it was from setting these two equations equal. Formulas. Part of what this is all about is making sure we remember what those are, kind of forcing you to look them up a little bit. Yeah. Okay, cool. Well, maybe you saw enough that with what we do today, it'll help kind of pull it together. You feeling okay about this? Yeah, awesome. Good stuff. Oh, some nice looking. That's nice shell drawings. Solid, man. Josh, you doing good? Cool. Hey, all right, yeah. Thanks. Yes, let's see. So wait, so this one, number 3 is y. Yeah, so this one looks like you're. Oh, I see. Okay, wait, you did. Yeah, so you took the function. So this one should be the top formula. Which one? The second. Maybe I'm looking at it. Is this 2?
This is the y-axis.
Oh, this is the y. Oh, okay. Yep. So the y-axis. Yeah, you're right. Okay, sorry. Yes, I was looking at my list drawing. Yeah. Yeah, I know. So I was confusing myself as well. So yeah, that's looking good. And then the y is 2, 1. So that's horizontal axis. Yeah. And that's. So where's the square? Oh, sorry. okay, 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 okay.
Yeah, it is x plus 2 to each of the x terms that's in there. Is it?
Yeah, so it's gonna be the outer radius of the parabola squared. Oh wait, which one are we doing? Y equals, yeah, that's your outer, and then your inner is that at just x.
Okay.
Yes.
Cool.
Yes. Curve minus pi. That's what I mean there. Yeah,
And the radius also is.
So the radius is the radius of the slice. So remember, so for those, you want to draw an arbitrary little slice and label it x. And then the radius is the distance of that slice to your axis. Whenever I'm spinning this around, so like here, this would be my radius then, from here to there. So kind of, yeah, a little bit.
That's a 2. The x is a 2.
When you say the x is a 2, what do you mean by that?
That's already 2.
The radius is going to change. Because the slices, because you're going to be going through there and slicing, and each slice has a different radius, and it depends on the x. Right? So think about the slices. Those are the things that are spinning around the axis.
Spinning. So it's gonna be x minus x.
That would be 0.
Mm-hmm.
It's not going to be that.
No.
No. We'll go through.
Is that a
Maybe
5 over there?
Maybe that's a 5, yes.
So would it be
Yes.
5
It would-
minus x?
Well, it depends on where we're rotating around. If I was spinning around this vertical line at
Yeah.
x equals 5, then it would be 5 minus x. Absolutely.
Okay.
What if it's just the y-axis?
Yeah, why don't we just talk about the first couple, huh? How about we do that? I think that sounds like a good thing to get us warmed up. So the key thing is get your picture made, figure out your bounds, and draw an arbitrary slice. So I like to do that and give it a labeling. I always label it just x because I need to know the coordinate of that slice. And remember, the game here is we're spinning these slices around either a horizontal axis or a vertical axis. So for the first one, I'm going around the x-axis. So that means I'm spinning around this thing, and I'm going to get yellow. Nobody's there. All right. So when I spin around the x-axis, I'm going to need washers, right? I'm getting a bunch of washers. The outer radius, look at my formula. The outer radius is this distance here. The inner radius is this distance here. So when I come to do my formula, first off, you've got to know which of these two to use. So for a horizontal axis, I'm going to use this formula. For a vertical axis, I'm going to use this formula. Because for a vertical axis, I'm going to get those cans. They're called shells, but I get little tin can outsides as I spin around like that. Versus these, where we get washers when I'm spinning that direction. So I'm going around a horizontal axis, so V is going to equal pi. My slices run from 0 to 4. Each slice has an outer radius determined by this top curve, this parabola. So right now, that's the outer. If I was using an axis above, then outer and inner switch places, and the line becomes the outer. So you gotta look at all the geometry. So here the outer is just for a particular x, that formula there. So this is going to be, in parentheses, x times 5 minus x squared. So this is my outer. And then minus this inner radius, which is just this distance here, the x function. Like that. So that's my first one. Is it still good? We're good? Yeah? Okay, cool, awesome. Let's do the y-axis now. So for this next one, we're going to have v equals, I'm doing vertical axis, so I've got shells. So I've got 2 pi integral, slice range. And this is where I need to have that slice labeled, because what I'm interested in is what is the radius? What is this distance here? That's equal to my radius. And remember how we're going to do this always right minus left. So you're always subtracting top minus bottom, right minus left, if you want to keep things oriented properly. So here my radius is just going to be x. And I could put minus 0, but I don't need to. This is just my radius. Radius of x slice. And then top minus bottom is literally just the height of that element that we're rotating. So it's going to be x times 5 minus x minus x. Top curve minus bottom curve. And then that's just dx. And you can see you don't need to simplify. Just like that. Are we feeling good about that? Yeah. So with that in mind, let's see if we can get these last 4 done, and then we'll get together and talk about them. If you get done early and you just want to start cranking on your web work, more power to you. But I kind of want to bring everybody along on this. Feel better than last week. I know Wednesday you're like totally finished. Yeah, okay, good. I'm glad to hear that. Maybe I'll start putting these up, and you can check yourself, and then we can talk about them as needed. This is when things start to change. Notice here how to get the outer radius here is all the way from the top of that parabola or wherever we're at down to that line. So I've got to take top, which is this, minus bottom, which is -4. And it turns into a +4, which makes sense. You're adding 4 to the normal formula radius.
And it wouldn't be 2 pi?
It would not be 2 pi, no, because we're going this way, Lou. We're spinning about a horizontal axis.
Yeah.
Yeah?
Would it be -10 to -4?
Did I, oh yeah, I mislabeled it. Yeah, it sure would. Thanks, Olivia. Yes, ma'am. This would be a -2 as well. Oh, propagation of error. And then the next one, the inner radius is going to be traveling from that -2 line up to the x curve. So it's going to be top minus bottom squared dx.
And you can just simplify that to plus, right?
Yes, sir.
Okay.
Absolutely.
Wait. No. Not if you're. Oh wait. JK.
Oh, you were going to bust me.
No, you're good.
All right. Yay, I'm not so, it's like I can't take more friedness today. My friedness has been manifesting all over. Nope. should definitely be drawing this stuff, at least facsimiles of it, so that you can see how the relationship runs between top, bottom, left, and right, all that stuff. So this is going outer, so it's going to be 10. Again, if you stick to top minus bottom, that's gonna save your mind a little bit of suffering. Don't just check. Make sure that when you compare, and if you got something off, we talk about it. If it's not making sense to you, now is a good time for this. You got it knocked out. Do you mind if I look? Or are you still thinking?
This one. That's the real expensive.
Oh. Yeah, so wait, number 4 was the, yeah, and then this one needs a 10 as well, because you're going around y equals 10. So your outer radius is going to be this distance to the y, right? Imagine what happens when I spin around that top
I'll
line.
just do outer. Okay, but. then
Yeah,
I'll just
so you
make-
have, outer and inner can change depending on where the axis is. Does that make sense? Yeah. So this is backwards, actually. Oh, wait, you did this. No, you did this right. I see. Yeah. The good news is subtracting and squaring won't matter, but like, just in
Yeah.
case, it would be 10 minus x, but
And then this one's
it's all good.
Out of 10 for this side as well.
Yes, sir. Yeah, I would take 10 minus, here, yeah, I guess it doesn't matter either place, but 10 minus that parabola curve, so that's also 10 minus.
So one's above, it's
Yeah.
and everything else.
Oh, yeah, let's take a look. So let's see, so then this one was number 5.
Actually, one is backwards.
Yeah, maybe so. So let's see, my line is 5, so 5 is over here. So yeah, this you would actually get a negative answer for this one, and you want positive answers. So always right minus left keeps you safe, right? So the 5 is here, slices to the left, so that's 5 minus x for my radius, and then top minus bottom, that rocks. So that's all good, but that should be 5 minus x. And then this one here, we were going around x equals -1. So what is my, so now, yeah, that worked out good for you there.
Okay.
Yes, sir, because you took the right minus the left.
So
and that
you got
worked
all
out.
right on the top minus left.
Mhm.
Okay.
Exactly. And then make sure that this parenthesis closes around this whole thing, because it's x plus 1 times that whole quantity. Yeah, but good work. Question? Cool. Oh, so nice. So, just a small thing. Here you want to do, I would do, it's going to work out okay, but just in case, the 10 is above the curve here, so you're actually doing bottom minus top. It won't matter when you square, but you see what I'm saying, because the 10 is up here.
So it should be 10 minus that.
And then these are backwards. So let's actually, before you even get, oh, that's okay. Let's think, I wish I was not proficient with my pad. Can you see the picture again really quick? Thank you. So when you're up here, when y equals 10, the outer curve is actually determined by the distance between that axis and the line. See how that's the outer, so this line becomes the outer part when we're up here. So it's going to be 10 minus x squared minus 10 minus the parabola function squared.
Okay.
Yeah, does that make sense?
Okay.
Oh, yeah. Yes. Oh, yeah, let's talk.
So when you do that class, you're looking at the
When you say when I do the x, which, oh, gotcha. Yeah, so x equals 5 is a vertical axis, yes, ma'am. Yeah. here's my slice, and that's labeled X. What is the distance between? It would, except you're subtracting backwards, so right minus left. Yeah, so 5 minus X is gonna be my radius. I think, which one are we on? I forgot which one we're doing. Yeah, yeah.
So it would be X minus, so it changes each time.
It changes every time, yeah, so that's why you gotta have a little bit of a picture, so 5 minus X is our radius. And that makes sense to you?
Yeah.
Awesome. And then just how tall is the slice? And that's just top minus bottom, so the parabola minus the X.
Okay.
Yeah?
Yeah.
Cool. Yeah? Okay. What do you say?
Minus
This?
the-
Okay, gotcha. So think of it, sorry. Sorry. So it's just the height of this little element.
Oh, so just the, okay,
Mhm.
that makes sense.
So it's top curve minus bottom curve here. Does that make sense?
Yes.
Okay. Awesome.
Okay.
Good. Yes, Lou.
So, rotating it this way. Right now.
Yeah, so around y equals 4, so around this.
Yeah.
Yep.
So, this is my outer radius.
The parabola thing, yeah,
Yeah.
the round thing is your outer, yes,
It's
exactly.
just confusing, cause like usually it's like strictly in one, quadrant, but it's in two quadrants.
And so, yeah, that would give us a chance to maybe exploit symmetry, like we could find half the volume and then double it. So that would be something, but the idea is still gonna be the same, you still got that axis there, and it's just that little region R. So you're doing it perfectly. So your outer radius is gonna be 4 minus x to the 4th. Your inner radius is 4 minus 1, constantly 1, yeah. That sound good? Awesome, good thinking. How are you doing? Oh, you're already like moving on. You moved on.
That's the way I look outside.
Oh, yeah, that's just beautiful. Just when you're, oh, but you got it?
Yeah, I picked it up.
Yeah, you did. Wait, what's this? So what is, oh, I see, okay, I see, there's some parenthetical
wrote it, it was
strangeness there.
weird.
Yes, oh, it's all better there. Oh, that looks great. Yeah, lovely.
Cool.
Looks good.
And
Yes.
I think what I'm doing wasn't right, cause it says.
Yeah, that's
So I
what-
set that equal to, I basically just found X volume is equal to 3, cause you said that the area is one of the house.
Yeah, that's perfect.
Spinning around.
Yes.
Is that looking right?
Well, there's something, so there's a little bit more, so can I see a pencil real
Yeah.
quick, please? So let's draw the picture really quick.
Have it.
Oh, okay, yeah, zoom out there a little bit. So notice that, so then we've got y equals 1 also, right?
Mhm.
So there's actually 2 intersection points, so
Oh, it wants between.
it's
them?
between those. Yeah. So you're gonna go from,
This is
so
one.
actually, how'd you get the square root of 3?
What was this one? Y equals 3.
Oh, sorry, okay, yeah, then that would do it. Okay, so y equals 3, I got it.
1 to the square root of 3.
So it should actually be negative root 3 to positive root 3, right? So, because see that line y equals 3 is going to intersect that curve in 2 spots, right? And they're actually the same distance away from x. One's just positive and one's just negative, right? So if that's root 3, then that's negative root 3.
Oh, it wants the entire chunk.
Yes, yes.
So can I do this and then just double it?
Yeah, but you're not getting the whole thing. If you put 0 here, then yes. But you're like starting in
There.
here, and actually, yeah, yes, you're starting like in here and doing a fragment of it.
What am I doing?
I'm not sure. You see that there's a problem.
With that
Yes.
one.
Yeah, think about it a little bit
Wait.
more. I'm gonna come check on my friend Cassie. Is this starting to make sense? Like how we're, okay, awesome. That's really the key thing. Okay, all right, good, all right, good. David, how's it going? You feeling like you got this? Is feeling good about it?
I feel like I'm on the right track, I'm not entirely
Ooh,
sure.
what's that 2x? Let's take yeah, let's take a look here. Where did the 5x come from? I'm curious about that. So let's see, we're doing x equals 5. So that's this line, vertical line represented by my finger. And you got the right formula. But, yeah, so we take this arbitrary x. So we take an arbitrary x element. That's the thing we're rotating. So that's indicated by x. The radius is this rotational axis 5 minus that x. So that's my radius right there, and it's going to change depending on x. So this should be 5 minus x, right? Minus left, yeah.
Okay.
And so that's, there's a similar problem in like that one as
Yeah,
well.
okay.
Does that make sense?
Yeah, okay, yeah.
How's it going? Feeling good about this? Yeah.
I'm not sure about these two.
Wow. Sorry. Yeah, I'm sorry.
I think we're just gonna do the radius.
Yeah, so, yes, agreed. So this one looks. So here we're using the 2 pi, right? And we're doing, so you kind of got a weird combo of formulas you're using. So you're doing, so like look at, I can't even see that shit from here, but the one with the 2 pi has the radius times the height, so that should be a times there,
Oh.
for sure. And now I agree with it.
Okay.
Okay, cool. But this one down here, I don't agree with, because let's see the pic. Okay, sorry, let me do it one more time. So we're doing around -1, right? So this thing right here. If this is my arbitrary x slice, how far is that x slice from -1? What is that distance? How do we find the distance? Right minus left.
So next one. One or minus negative?
Yes, which is,
Just x plus one.
yeah, so that's what that, so that should be x minus -1 there.
Okay.
And then the rest looks great. Cool. Let me get the rest of these up here. And if you could, do me a favor, when you get done with that, just like pop it on a piece of paper with your name on it so I can just remember that you were here, because clearly I can't remember when people are present all the time. So. Let's see, so then this one's going to be, the key, the answers are right here. The key thing is understanding the answers. So let's see, x is 5, we're going to go 2 pi, integral 0 to 4, outer radius is going to be 5 minus x, or radius is 5 minus x, and then top minus bottom. This one, and then number 6. The axis and the slice change roles. So here we have v equals 2 pi, integral 0 to 4. The x, when you rotate around -1, I've seen this in a couple of folks' work, you do right minus left, so it's x minus -1. So it should be x plus 1 in effect, but it's probably safer to just write it all out, and then top minus bottom. So if there's anything up there that like you're confused about, let's talk, and I'll come make rounds. Yes.
Okay, so I started over,
Okay.
and I drew a little graph from here.
Yes, ma'am.
A little shape, because I like them.
Oh, it's between y equals, oh, I didn't know it was between these two, okay.
Yeah, it's between
Is this a
y-
different problem, or?
No, it's the same one, so
Okay.
that's why I thought it was gonna be between that and that, like that little part and the 3. Because in my brain,
Yeah,
this
yeah.
one, it was
So you
like
would-
shoot,
Yeah.
and then that's y1,
Mhm.
next one. And then up here, 3, 3, 4, 5.
So you're doing the region wrong,
And then I thought it was
unfortunately.
there.
Yeah, no, so here, let's take a look. So let's try, it's okay, so let's do y equals x squared, that's easy,
Mhm.
that. And then y equals 1 is that.
Yes.
So we are looking for the bounded region between these two. So it is this. And we're rotating that around that.
That makes life so much easier.
Doesn't it?
Yes.
There
okay.
you go.
Thanks.
It's probably gonna work out a lot better now.
Yeah.
Yes. Oh yeah, that'll be cool. Yeah, send me an email. That'd be great. Yeah, why
How can
not?
I write it?
Well, no, oh God, please don't rewrite it, Fernanda, no, no. Actually, just let me look at what you did, and then, oh shit, let me just take down everybody's name, who is here doing this. That's all that matters. I've looked at everybody's stuff, now let me just look at it and make sure it looks good. Yeah, that's, well, there's also that, isn't there? This all looks good. Yeah, beautiful. Yeah, it's great. No, it's so nice. I'm just gonna take down your name. This looks so good. I'm gonna come around and look at everybody's stuff, but I'm gonna make a list of who's here and just give you credit for being here. And instead of let me check. And look, how do you feel about this here, Lou? I'm taking them together.
Feeling a little weird.
Okay, okay, let's look then. That's important. So let's go through. So, the first one, that's beautiful. Yeah. The second one, that's beautiful. Third one, we're going around y equals -2. So this square should be out here. Because it's square, there's a whole difference here. Same thing here.
Yes.
And then is this, what is this that's written in there? It looks like x times -2. Is that what you mean? What did you change it to, sorry? X, so is it x times -2? Is that what you said?
I don't know.
No. What should it be? What is my inner, so this is your, notice there's no multiplying going on up there, right? So we're just doing tops minus bottoms, left minus right. So here we are going around, which one was this? Y equals, is this the,
Negative y.
okay, got it. So we're going around y equals -2. So your outer curve, I love this, because the parabola's on the outside, so you take that top minus -2, square, beautiful. Here, x is the middle, that's gonna be the inside. So how far is it from x to -2? The answer is x minus -2. So that should be x minus -2. That makes sense. Does that make sense? Okay. Cool, solid. So what,
Same thing.
same thing? And should it be x minus 10? So before you write it
It
again,
should be
what's
10 minus x.
perfect? Yep, and then this one here, and this one here should also be 10 minus that. So let's change that too. And then the squares need to go on the outside as well. Yeah, beautiful, beautiful. Does that look, when you look at that, does that feel okay to you?
A lot better.
Okay, awesome. And then here we've got, so now we're doing 2 pi. So this is our outer radius, I agree. And then 5 minus x, that should be times. Because this is, so see, so let's check out the formula. Read that one, it's a radius times the height of that element. So it's gonna be times how tall is that elephant? It's not 10, there's no 10 in this problem. It's all good. So how tall is the little slice inside there? Yeah, exactly. Yes, it's this one here. So how tall, what's the top edge? What's the y coordinate of the top edge here? For a particular x, how high is this thing?
How high is it?
Yeah, how high is it? How tall is that parabola? How do I figure out the y coordinate right there? So we've got an x, we've got a little slice. What is the y coordinate above that x?
X minus that.
It's going to be the equation. I think you're thinking something. I'm asking for something. Just the equation here. So for a particular x, the height is just x times 5 minus x. Does that make sense? Then what's the inner? What's this lower edge? So the top edge is x times 5 minus x minus what is? There you go. Yes. So it's just the equation of that top curve minus the equation of that bottom curve. Don't need to like do any algebra or anything here. So this thing inside here should be, wait, we're on this one, thank you. Yeah, so this should be x times 5 minus x minus x, okay? See, wait, I think we're changing. Oh, sorry, I couldn't see it, sorry, it wasn't. Let's rewrite it again and let me take a look. I was looking at the wrong damn thing when you asked me. Okay, so yes, that's beautiful. No square. No square. Squares are only on when we rotate around a horizontal axis. Okay, cool. And then this one, so now we're going around x equals -1. So first slice, how far is x to -1, which is over here? So we do right minus left,
So it's X minus -1.
which it would be simplified to not that, but because you have x minus 1 there, as though we were taking the x coordinate minus 1, but you're taking the x coordinate minus -1. What's that turn into? Let's just write it out. Look. This is so tiny. You've got such tiny, it's all tiny and compact. You've got so much space here. So we're taking x minus -1. There's -1, taking the distance between the x and the minus 1 turns into x equals 1. See x here, the x coordinate is the distance from this point to the y-axis. And then we're adding on an extra 1 unit. So it makes sense that we're just kind of adding 1. Does that make sense? Yeah. But if you just do right minus left on those coordinates, then you'll be safe.
Okay.
Yeah. And then, so this one x. Yeah, so that should be x plus 1. And then just, hold on a second. And then this should be times top minus bottom. So that's a time, so fix that one really quick. I go right back. Oh, cool, stop. So, I'll double check. I thought that maybe those were like, I will fix those things. I'll fix it. So, okay, so sorry about that. I made you create this stress.
No, you're totally fine.
Okay, you know all this.
Yeah.
Awesome.
Thank you.
All right, bye. Let's see, who have I not? May I look? Thank you. Let's check through these. Lovely, even with a note with exclamation points, so nice. Can I just look at this? Is that okay? Did you wanna? Let's see. Yep. Yep. So this one, so let's talk about, oh no, wait, never mind, you're good, sorry. Yeah, it's all good, this is great. I'm the one who needs a talking to. Yeah, beautiful. Awesome. Are you ready to have me look through those?
Yes.
Yes? Okay, beautiful.
I see one thing I messed up.
You wanna fix it?
Yes.
Go ahead and fix it. I'm gonna take a look, check out Josh's work here.
You can help on the
Sure.
my work.
Yeah, let me just do this sanity check here first so I can say I did it. Yeah, this all looks good. Cool, beautiful. Let me just finish this and I'll come right back. You're next to the screen. And I think I've seen this. Yeah, it looks good. No, I think I remember. It looks really good because we talked about it. Yeah, okay. Okay. This was the yes, gorgeous. Thank you. Yeah. Thank you. Well, where are your integrals on here, Carlos? Are they on here? Oh, you just got it. You don't have the number.
Yeah.
Okay, got it. Oh, okay, gotcha. I see. You were separating them. You were
Yeah.
classifying. I see. Looks good. Looks solid. Alright. And Lewis on yours. And David, are you ready to have me look at
Yes.
those? Okay, beautiful.
Lovely, gently.
Yes. Yes. Solid. Good stuff. All right, my friend. I'm gonna walk around so I don't flip my Berks out into the wild air here. I think that's gonna be good for anybody. Yes.
I also have a question on a couple of them.
Yeah.
This is number 3.
Okay.
And I'm not sure if I got the limits.
Okay, so no, that looks right. That's
Maybe right
good.
here. This is good.
Yeah. Oh, okay.
Because I was just trying to rework it, but then I realized it wasn't the same exact thing.
Yeah, no, you got the limits correct. Those are perfect. So -1 to 1, and then around y equals 2. So, oh wait, so yeah, 2 minus. I love that. That looks good. So let's yeah. Oh well, yeah.
I'm just trying to square it.
What the fuck? No. This is that is bogus. You got to foil that out, my friend.
Okay.
Yeah, that's your problem, Josh. It's not that bad. I mean, it's just like 4 and plus x to the 16th, and then the outer and inner terms are just going to be -4 x to the 8th.
Okay.
You see what I'm
That one
saying?
needs to be foiled.
Okay.
It might be the same.
Yeah, there's going to be a lot of foiling. There's a lot of algebra in this assignment.
Yeah, I think.
So let's take a look. Okay, so y equals x, y equals square root of x, around x equals 3. Okay.
Probably not. Oh, this is.
Oh, okay. I was like,
This is
whoa.
number 6.
Yeah, I was like,
This
that
is
is,
5.
there's no way we're gonna get it out of that. Okay, so 3 minus x times.
Interval right.
Yeah. Oh, yes. Yes, your interval is quite fine. So, and this is top minus bottom. That's your radius. Boy, that all looks good. Oh shit! Yeah, you gotta multiply this out before
Okay.
doing what you're doing. Yeah, you
That's
created a
definitely
new
a problem.
branch of math there.
Then I think this one might be the.
I think yeah. Okay. So that's good though, right?
Yeah,
Like you're
okay.
doing the mechanics
Yeah.
right. It's just the
It's a
algebra
common theme.
going to
Yeah,
hell.
algebra.
Yeah. Do you want to look at this one here? Okay. So we got 1 x 0, and then x equals 1. Okay.
cool. Awesome. Yeah, yeah. And we're going around what line? Negative
Y.
Okay, so y equals negative. Oh, y equals negative. Okay, cool. So yep, I agree with that. I think I know what, I got a feeling what's gonna go here. Yeah, that's your problem. Yeah. Oh, Lord. Fix that shit up.
Hey friends, when you're doing that web work, because I don't think Josh is going to be the only one having this problem. Let's talk about it. We're math, and some of us are math majors in here. And let's just remember this moment when I said this, that something squared, something plus something else squared, is almost never equal to the sum of the squares. Foil that shit. Foil that shit, okay? You have to multiply it all out. Josh isn't the only one. I hope you don't mind, Josh, because I like
I'm
literally like this happens
Yeah.
24/7. If we could gain power from people making this mistake, we could power the whole world. Anyone, do you need consultation? Are you good? Okay.
Is this right? I feel like it's really wrong.
Okay, let's take a look. Outer square.
Okay, wait, I better think about the problem. So we got y equals MC4, y equals b. So we got that little thing like this. And we're going around here. Okay. So yeah, we're not doing top minus bottom. That's not the problem. But it's part of the problem. Just thinking about it. So bless you. So you got the 4 up here, and you're going to subtract off 4 minus the x to the 4th. So that's your outer radius is 4 minus x to the 4th. Can you picture that? Here, let me draw.
I can picture it,
Yeah.
but
Yeah, so let's draw what we got here. So we've got a little region like this, and this is 1. This is minus 1, right? So we're
Yeah.
taking that and we're spinning that around 4. So my outer radius is going to be that distance. So top minus bottom, that's x to the 4th, says the outer radius should be
you told me you were something like this way. This is about the y-axis.
This one, well, this, I don't know what problem that, but this is around y equals 4.
Yeah.
So this is around a horizontal axis. I don't remember having the conversation you were relaying to me. I do not remember that conversation, my friend. Let's just look at this conversation. So how about this? So does that make sense that that's the outer radius?
Yeah.
Okay, square minus inner radius. So what is my inner radius going to be? So that's just 4 minus what?
4 minus,
My top is flat.
4 minus 1.
Yeah. So 4 minus 1 quantity squared dx. So this is my formula. So now, next step, let's talk about simplifying because that's where something else is starting to come from. Something else looks good. This has got to get foiled because it looks like you just brought that in and squared that. And maybe didn't square that one too, so that 2 got a little bit of selective action here on the squaring. So you gotta foil that out. So you need to literally work it out. 4 minus x to the 4th, 4 minus x to the 4th, and foil. Does that make sense? So what's that gonna be? Yeah. Yep.
to the fourth plus x to the 8th. There you go. So that's what that whole part there is going to be replaced with that formula. And then minus 3 squared, which will just be minus 9. So take this, subtract off 9, a little simplifying, right? 16 minus the 9. Beautiful. Now that's your integral.
Okay.
All right?
So it's
Yeah.
just so confusing, cause like when I think about like spinning around an axis, I think about it like as like a pole, and then you're like spinning around it, you know?
Yeah.
But then it's like the opposite, like you're like looking at like the shape, like with a horizontal line up here.
Yeah. Well, think about like something think about like just even like an atom, right? Or something spinning freely around at a distance from some central axis with nothing attached, so, or like a centrifuge, right? Like maybe we were trying to model the inertia in just the heavy part of the centrifuge, so we'd have to like view that as a thing separated from its axis by a distance. It's good for you. You're just getting stronger. Yeah, yeah. I'm glad it's confusing. That means you got something to learn.
Yeah.
Absolutely. That's some physics. You're gonna be doing that stuff in physics. I got a feeling. Hi, Fernanda. Okay. Yes. I've been talking to everybody about this one, so this is a good one to talk about. Yeah. You did a great job setting it up. So this is beautiful, but yeah, now we're having trouble. So, so we've got y equals 1 is one of our curves, and then y equals x to the 6th. So the thing we want to do is set 1 equal to x to the 6th. Okay, cool, cool. Yes, close. Well, this is good. You're doing great stuff. We're just, yeah, that's nothing. So here, let me show you how to kind of do this. So, oh, thank you. So we've got x to the 6th equals. Now, one thing you could just do is take the 6th root of each side. You gotta remember that when you take an even root, you need to put a plus or minus in front. That's all. So anytime you take an even root of something, put a plus or minus in front. So what's the 6th root of 1? What's 1 to any power? Yeah. So this is just x equals plus or minus 1. Does that make sense?
Yeah.
Yeah,
So
yeah.
it would just be
Yes, ma'am. Oh, perfect. And then what you've done here is beautiful. You gotta FOIL that out. So you gotta write out 4 minus x to the 6th times, and then FOIL and make sure everything turns out pretty. But you, yeah, great job. Really great job. You're welcome. Anyone need consultation? Oh, yes, Kendra.
so working on
Cool.
number 6. So it says so I can but it's going to be right up here. This area. That's what.
Okay. Oh, wait, did you just add 1 to it? Wait, what happened?
It's rotated.
Oh,
on
okay,
Y.
gotcha. I see what you're saying. Yes, plus 1, yes. I
Yeah.
see now. Okay. So this looks good. So 1 to 5, 1 over x plus 1 minus. So you're not subtracting off the inner part. That's the problem. You're basically finding the volume of this whole solid all the way down to your axis. So you're acting like from this curve down to your axis of rotation is the region. But your region stops at y equals 0. So do
Oh
you see what I'm saying?
goodness
Do you see what I'm
gracious.
saying?
Yes.
Yeah, yeah, so you can fix that easy.
So
Just subtract off
the,
the volume of that inner part, so it's gonna be
so it'd be
minus.
this minus the 1 of the
Yep. Yep.
Okie dokie.
Yes.
So this is just the outside. That I
That's the
can-
outside.
and then
You
I
just
can
yep, exactly. It's
the area.
if you can figure it out, what is it going to be?
It's just my. I need to, like,
Do you want to think about it? I'll let you. I'll leave. It's hard to think while I'm watching. Things going well here. Anything? Yeah, great. Oh, the region. Okay. Let's take a look. So let's add. Oh God. Yeah. Yes. So. I'm all good. Thank you. Thank you. I appreciate that. Where we moving on here? So first off, you got the y equal x to the 4. That looks like a problem. And then you've got this y equals 64x. So sometimes drawing these things to scale is not the most helpful thing to do. So like, I just know it's a line with a slope, right? And so at some point it's going to have to intersect this parabola. Does it kind of make sense intuitively that they would intersect out here? Cool. So we just need to figure that out. One of the intersection points seems to be 0 for sure. But let's figure this out for real. So x to the 4th, when does that equal 64x? So now I would actually convert that into this equation. And then factor out an x. So x equals 0, or x cubed equals 64. What would that be? So what cubed gives me 64? It's tough, yeah, x equals 4. It's just the cube root. Like 4 times 4 is 16, times another 4 gets me 16. So here's your integration, and you just needed to solve this. That picture was probably very confusing, so I just usually kind of just wing them myself. You're welcome. Yes, ma'am. Well, how did we go from here to there? How did that square root turn into? I don't understand that. Let's check that first one before we even do anything. Let's just check that. So we're going around x equals 4. Is it this one here? Okay, so we got square root of x, y equals 0, x equals 4. Okay, so this okay, and then we're going around x equals 4. Cool. So right. So that needs to be an x and x. So when I go on that way, I would draw this slice. I just want to do this here. Let's go see some. Let's make sure draw that slice. It's an arbitrary slice. You got to for this marathon because the radius is going to change as that slice changes. And we're adding up all those different little cans that we're producing. So this should be 4 minus x. Does that make sense? So in these problems, that radius is almost always going to change as you slice through your region. And then this looks great, but that's your problem. So now you got to foil, right? Those over there,
So like this X just represents like all these.
Yes. Yes. I'm glad we had that talk. That's important.
Okay.
Does that sound good?
Oh, also,
Yeah.
we're not gonna be here on Friday.
Oh, okay. I'll record.
Dude, when is this due? Dr. T, is it tomorrow? Whoever can do tomorrow,
Should we change that?
to Friday, day after.
Yeah, what is today? Today is
Well,
yeah. Sure. I'm gonna talk. We can do a little more of this on Friday. I do have a story I want to tell you on Friday. So about calculus. Yeah, exactly. I have a calc story to listen to, and that's in exchange for moving the deadlines. Does this sound like a fair deal? Absolutely. Okay, great.
Let me try to remind myself, Josh. Let's see, where's my little list of? Okay, done, or will be done. What is that? What's that? What did you say? Oh, that's what I was thinking too. Now I know what you said. I was thinking the same thing. Yeah. Cassie, how's it going, friend?
Good.
Is it?
Yeah.
Okay.
I just walked in.
Oh, okay, all right,
think
okay.
so. I
Yep.
just re-walked
Don't
back
have
in.
anything to talk to right now? Okay.
Thanks.
Well, this isn't due till Friday either, so
Yeah.
we got more time to talk. Josh did you all well by asking for a reprieve. Oh, what's this? Is this yours? Oh, yeah. Lord. Don't lose that.
Yeah, no.
Doing good, Carly?
$5 to
25 to replace it. It sounds like you've had to replace it already.
Yeah.
Oh, jeez. Do you want to talk? Okay. Okay. Yeah, oh, no, I don't know. I was gonna say no, but that number looked too big, but that's what they gave you, right?
Yeah.
So yeah, that looks okay. So what are we rotating around? Oh, the x-axis? Yeah, and it's nice, so 49 is just, this is square root function, so that's a 7 right there. Does that make sense? Right, the square root of 49 is 7. Thank you, Josh. I'll see you on Friday, sir. Correct. Not that it actually matters in the problem, but especially if you're going around the x-axis. Thanks, Dave. Thanks, have a good one. See you Friday. It's a lot of ice you got there.
This is right. So we're rotating around
So we're going around the x-axis, so we're going this way. Yeah, so let's, oh, erase the thing up there. So this is. So if we're going on the x-axis, outer is radius squared minus inner radius squared. You're kind of like, I see. You see what I'm saying? Kind of a hybrid
kind
thing.
of combining.
You are combining some things there.
So, for the whole thing. So for going that way, this is gonna be.
Perfect, that's your outer. Quantity squared, beautiful. Yep. Yeah, there you go, Lou. Squared, beautiful. That's it.
Okay,
Yes,
alright.
good stuff. And what's that gonna simplify to?
This,
Just wanted to check while we're here together. No, it's 2 squared. That's why I was like, let's see.
foil.
No foil, there's no
No?
foil needed. No, it's just
2 squared x squared. Because you can just distribute that exponent to a product because there's a product inside. Here's the thing. So if you have something times something else to a power, and that's times, then that power can come to both these. It's when there's a plus in there that I can't do that.
Okay.
Yeah.
So, 2 squared times x squared.
Wait, what? 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 Oh, good Lord, what's going on? Yes, correct. Yes, sorry, yes, Luke, perfect.
Same does not hold for these.
That is correct.